Okay, we're finally at the point where we're ready to do some programming using lists. So I'm going to show you some examples of lists in Python, and then you're going to get some exercises to do for the next couple of days, probably about 3-4 days. I'm going to probably have to do one other video this week as well, so probably this set of exercises and then one other one. So today is examples using lists. I'd recommend to stay on task that you start this on Monday or Tuesday if you can, because probably on Wednesday or Thursday I'm going to post something else. So Visual Studio, there's the last program that we did. I just did this video, so I'm kind of doing them all in a row. So we're going to create a new file. And this is how we create a new file. So we have our Python. This right here represents our folder that's currently open, Python. And if we were to go to our yellow folder icon at the bottom there, you would see that there's one file in it, string as list. Create a new one by clicking on new file right there. And we're going to say lists examples.py. Okay, so listexamples.py. You can see that it's very much like Genie where there's a tabbed view up here. I don't even want string as list open anymore. If you don't, you can close it. It'll still be there. Like, you can do that, and as soon as you open it up, it will be available. Wait a minute, if I close it, yeah, it goes away. And then if I, oh, there it goes again. So yeah, you can, I'm going to have it closed for now. But it's easy to access all the files in the folder. Very, very nice. So listexamples.py. First of all, I wanted to talk about what lists are. So a list, and I'm just checking out that everything looks good on the video. A list is a collection of variables. I don't know if things look good, but it's my face anyway, so you're stuck with it. Anyhow, okay, so a list is a collection of variables of all the same type. That's what a list is. These could be integers. They could be, so those are whole numbers including 0, negatives, and positives. They could be floats. And a float in Python, just to refresh your memory, is any number including decimal numbers. There's a precision limit to the number of decimal places you can have. It's not important for us to know because we're never really going to go beyond it. But there's different floating point positions that are available. The last time I had to deal with that was when I was doing C programming, and that's not going to really come into effect in the next couple of months anyway. But just good to be aware that there is a limit. We're working with a machine that only allows us to store discrete numbers. We're only allowed to store numbers. You could not store pi up to an infinite number of digits on a computer. You can approximate it, just like you can't really do a random number. Everything is discrete and countable on a computer. Okay, the other thing that we can store in lists are booleans. If you're in the computer engineering class, you already know that, or it might be more familiar to you. But anyway, a boolean is either true or false. We could also store strings in lists, and there's different reasons why we would do that. When you're writing a program, sometimes a list will save you a lot of time. A lot of times when you're writing a program to solve a problem, figuring out what kind of a structure to use to store the data and to store the information and to manipulate it is half the battle. And a list is one of the, well, probably the first structure that we're looking at in this course. So from my notes, what else is a list? They are used whenever we have to keep track of a group of things in the computer's memory. Examples are a contact list on your phone, a collection of phone numbers, a list of bank transactions, very important. You know, every bank account, most people do their banking online, especially now. Even before March, everyone was doing their banking online probably on their phone, and there's databases that keep track of everybody's transactions. A list is one data structure that could keep track of things like that. Any group of variables that are, but they have to be all the same type to be in a list. That's the thing. Okay, so let's do an example of a list. Before we go, where are we here? I'm just getting my window set up. So we have list examples done. So we can start by typing out some values. This is list example. So data. I'm going to call my list data. That's the name of my list. And to give it some values, you can use square braces. We haven't done this before. So far we've only seen strings as lists. But this is an actual bare bones list. So we're going to put the equal sign and then square braces, and we're going to have a comma separated list of values, all the same type. So I'm just going to put in some random integers. This is going to be an integer list. Remember, Python infers what kind of variable or variables lists or variables or variables that lists are made out of based on what the values you have. And in this case, it's going to infer that they're integers. So we can do the same thing that we did before. We can print data at location 0. That's going to print out -1 because data at location 0 is -1. What else can we do? We can print, I'm just going to print a bunch of stars here because now we're going to do for loop. Same as what we did before. So for C in range 0 to len of data, I'd rather you do len of data, so we know how to use that now. Print data at location, the counter variable C. So let's run it. To run it, you go down to the bug. Now, Visual Studio Code, I don't think I mentioned this in the last video, it saves it when you run it, I believe. It saves it automatically. It has to. So yeah, it's not asking me to save it. It saves it automatically. So what do we have as our output? We've got a -1 for print data of 0, then a bunch of stars, and then finally all of the data on separate lines. Why would we want to print them on separate lines? We don't really want to print them on separate lines in a real program, but we do want to access each data point individually. Why don't we change this program around to make it more useful so that we only print out, so I'm going to put a number sign, our hashtag. Remember, that's a comment. I'm going to say, this program only shows values that are greater than 20. Only shows values that are greater than 20. So we're going to keep most of this program the same. You can put a hashtag or number sign in front of that. Data 0, we don't really want that right now. And we're going to add an if statement. So we do want to cycle through all the values in the data list. So we do want to go from range 0 to len of data. But we want to do some processing here, some pre-processing. We don't want to just blindly print everything. We want to check to see if it's a value greater than 20. So I want you to picture for a moment, there's a bunch of blocks, and each block, maybe they're kids' blocks. I've got 2 little kids, so I'm always thinking about that kind of stuff. But we've got blocks, and each one, so one of them has -1 on it, one of them has 2 on it, one of them has 0, and so forth, all these data values. And we have a robot that comes along, and the robot's given a task to select all the blocks that are greater than 20, and how might it do that? So think about how the robot would do that. As human beings, we're much more sophisticated. Our brain works in a much different way. All we have to do as human beings is just to, we can actually look at several things at once and pick something out, because of the way our brain is structured. But a computer has to look at, or a robot has to look at each thing individually and determine. It has to make a determination on each thing, doing a comparison. So an if statement can do that. So here we go. I'm going to press tab in there. The if statement's going to be inside of the for loop. So if, remember if statements, if data at location C is greater than 20, don't forget to put a colon at the end of that if statement. If statement is part of one of the statements, structured statements that has a colon at the end of it. And then finally, the print statement also has to have another tab, because not only is it inside of the for loop, but it's inside of the if statement. It's nice. Visual Studio Code does this. It has a line dropping down that it shows where everything is lined up, so you can clearly see everything that is to the right of the line is inside of the for loop. If I was to have another print statement here that says all done, you can see that that is not inside of the for loop. It's not to the right of that vertical line that's dropped down underneath the for. Python requires you to tab things in. You can't use spaces, so you couldn't do something like this. Like you couldn't do that. I don't think. At least it shouldn't let you do that. One of the reasons why it does that, the historical reason, is because Python wanted, I think it was meant as a learning language, which is what we're using it for, and it develops some really good habits. So let's run it and see that it only prints out, click on run debug, and then Python file, only shows the values that are greater than 20. Okay, so we're almost done here. I've got another program I'd like to show you how to change values and then show the updated lists. So let's say that this was the data set that we were given, but we're going to change the values. I'm going to get rid of this line. I'm going to say change some values around. So let's say that we wanted to say data at location 2 and make it equal to 100. And so let's just take a step back. Where is data at location 2? Don't forget we start counting at 0 with the locations. So -1 is at location 0. 2 is at location 1. 0 is at location 2. So the 0 is going to be changed to 100. And then finally we're also going to do, just for the heck of it, data 0 equals data at location 0, which is previously -1. We're going to say this. See if you can remember what this does. Remember the input statement. So the input statement gets a value from the user. In Python 3, which is what we're using, by default it gets a string. We're casting it as an integer, or we're converting it into an integer, and store it before it gets stored in data 0. So now when we run the program, it's going to say, I hope it works in Visual Studio Code. I hope input works. I've never tried this actually. Oh, Python file. Click on Python file. Enter into good. So enter a new value. I'm going to put in 99. And there we go. So location 0 was changed to 99. It shows all the values that are above 20. And notice in this program we're changing the values around. That's all I wanted to show you. What I'd like you guys to do for the next, on Wednesday, let's make it due on Wednesday, is the exercises that I'm going to be posting on Classroom. Bye for now.